with HCl or HBr to produce alkyl halides. If it's a tertiary alcohol, the reaction will proceed through an SN1 reaction. Here's an example. It's also possible that you could start with a chiral alcohol, such as this one. The same reaction with HCl or HBr would produce a tertiary alkyl halide, but in this case we would get a racemic mixture. Let's look at the mechanism. So if I look at the chiral alcohol as an example, and again we're treating this with HCl, and that's always provided as an aqueous solution, so the acid available is hydronium ion. The first thing we would do when an alcohol is treated with acid is we would protonate the alcohol. So for that we start with a lone pair on the oxygen, pick up a proton from the acid. Proton transfers always need to show 2 arrows. So we draw what forms in that step. Which is the protonated alcohol. Now this is considered a good leaving group, so it can leave. When it leaves, we get a tertiary carbocation, and carbons that are positively charged are trigonoplanar, and so they're sp2, they're trigonoplanar, and they don't have any groups pointing in or out of the plane, so we would just go ahead and take this methyl group that was pointed back and put it into the plane. We'll also draw the byproduct of that step, which is water. There's some chloride because we initially started with HCl. So there's some chloride in solution, which will do a nucleophilic attack. And when it does a nucleophilic attack on a planar carbon, it can attack from the front or the back with equal probability. And that's why we end up with a racemic mixture. If it attacks from the front, the chloride will end up above the plane, and the methyl will be pushed back. And if it attacks from the back, then the chloride will end up behind the plane. The methyl will be pushed up. Okay. So if the alcohol was primary or secondary, the reaction would occur via an SN2 reaction. So let's look at a primary alcohol and then just know that secondary alcohol would behave the same way. So if you have a primary alcohol being treated with HCl or HBr, the product will be a primary alkyl halide, and the mechanism is a little bit different. We'd start with the alcohol, and again it would pick up a proton from hydronium ion. So we get a positively charged intermediate, but now the alcohol will not leave because primary carbocations are too unstable to form, and secondary carbocations form very slowly. So instead, this will wait around until our strong nucleophile in chloride will attack. It can attack and we can lose water simultaneously, and we call that an SN2 reaction. Here we form the product and some water as a byproduct.